welcome and hi to all. This is the continuous video as promises for divisions. Okay, it's slightly similar basically for the multiplications. So that's why after this we're going to look into divisions. I separate the two videos, multiplications with also divisions. I separate because I don't want you to be confused, because there is several, like the flow chart, the step, we need to like focus in each of this. So each step there is several things that you need to know. So I hope that before you go and proceed watching this video, please try to do all the example, exercise, especially for solution. As I mentioned to you, solution 2.2 and solution 2.3, please try to do it. Maybe I'm going to ask you to submit, or maybe I'm going to ask you to present in our online class. What else? I think it's only that. Exercise, solutions, yeah. It is not hard, but the problem is you need to memorize all these steps. Similar to division, you're going to have also a methods, which is the division algorithm using the hardware, which is the first hardware divisions. You're going to have a flow chart also, but the step is different rather than for the multiplication. So you need to remember both multiplications and also divisions algorithm using first hardware. So these methods, there is their own step. So please try to do it all. How are we going to memorize it? It's easy, which is you need to do a lot of exercise. Change the value, repeat the step, then you can easily remember. So go back to our slide here, divisions. Same and similar to the multiplication, you're going to have like multiplier and also multiplicand, isn't it? And you have product. But in division, you're going to have dividends and divisor, and you have another, which is quotients and remainder. For the multiplication, you only have a product, right? But instead for the division, you have quotient and also remainder. So you can see two operand we call as dividend and divisor. The result as quotients with the second result called as remainder. Let's take a look. Another way to express the relationship between the components from all these four, dividend, divisor, quotient and remainder, you need 1, 2, 3, 4. Okay, dividend, you're going to be equal to quotient multiply with divisor plus remainder. So this is the equation you need to also remember, but this one is like a relationship between each other. Sometimes you need to apply another method, which is the one that's similar to the multiplier last time. It's okay, we go and take a look into one by one. Okay, infrequent program use the divide instruction just to get the remainder, ignoring the quotient. So there is a keywords when you're going to apply this, which is where the remainder is smaller than divisor. But it's okay, you can see if let's say under divisions for unsigned integer, it is totally similar to your mathematical arithmetic. You can see if you have 147 divide by 11, what you're going to do, this is decimal number, you need to divide it, you need to convert it into binary first. Into binary, you're going to get dividend and also divisor. So this is equivalent to 147. If you direct convert, I don't want to show you how to convert. This one is directly, you can use calculator, but it's better for you to play around how you're going to convert from decimal to binary. Please check back your digital logics note, and previous video also I already shows you how to convert. And for divisor, 11 here also you can see when you direct convert to the binary. And when you divide, you're going to divide as a normal mathematical form. So let's take a look. 1011, you got until here, so you have 1 and you will get 1011. So you minus, like a similar thing. If you have subtract, please refer to subtract, refer to subtraction table. You will get 0 minus 1, you get what? You're going to learn you're going to borrow from beside. So you will get 0 minus 1, you get 1, right? And you're going to lend or borrow. 0 minus 1 similar. So it's continuous. You can try to deduct or subtract it. So after that, divide this using a normal divisions. Then you're going to have like partial reminder, partial reminder, and also final reminder. So this is final reminder and this is your quotient. Your final reminder will be 4, equivalent to 100, and quotient will be 13. Please try to do in terms of like 147 divide with 11. Is it you going to get a similar answer or not? Rather than using the binary, you can compare the answer. As usual, unsigned integer like is too direct, you can apply normal mathematical. But when you go to signed integer, this part is always having a problem, especially when you want to, especially when you have an error, when you have a, what is the keyword? I forgot already, but error while using the arithmetics. So arithmetic program, which is like adding, multiplication, subtraction, divisions. So that's why you need to use the second complement or two complements to make both dividend and divisor positive. Perform divisions. Make both dividend and divisor positive and perform division. Make the sign of the remainder match the dividend. So you have 1, 2 now. No matter what sign of divisor and quotient, so you need to remember these two, which is you can summarize these to these rules. If you have positive, your quotient will be positive, your remainder will be positive. You need to apply, okay? If you have positive for your dividend, your divisor will be negative. What you're going to get, quotient will be negative, remainder will be positive. It is fixed, okay? This is the rules you need to apply. If you have dividend negative, your divisor positive, you're going to get quotient negative and remainder negative. When you have both dividend and divisor negative, your answer will be, for quotient will be positive and remainder will be negative. So please make sure you memorize these rules. But you can negate the quotient if dividend and divisor were of opposite sign. So all these rules is important. That's why I was thinking divisions is much more like harder if you compare to multiplication, because all these rules I had to memorize. Okay, next, instead just using these rules, you can also directly use the method, which is, we call it as first versions of division hardware, which is similar to the multiplication ones, but different in the step. So the step now, first you need to subtract the divisor, register from the remainder, blah blah blah. You can read it later on. I prefer to show you the example. Then you need to have option, test the remainder. You need to see whether the remainder is more than 0 or less than 0. If more than 0, you're going to go to 2a, and this one is 1, okay? And then if remainder is less than 0, you're going to go to 2b. And next is 3. After 3, you need to calculate whether, it's depend on how many bits you have, okay, until done. So if let's say it's mentioned 4 bits, so 4 times you need to have 4 bit numbers, not including 0. So you have, like, if let's say altogether it's 5, so until 4 times. Divide 7 by 2. Let's take a look. Before that, I need to copy this flowchart so it's easy for you to refer and see inside the example. Is it okay here? I think maybe at here. As long as you know this is step 1, step 2, step 3 until step 5. It's quite different. Later on you can see what is the difference. This one is repeating, adding of, like, if let's say your bit is 32, you're going to repeat until 32, you're going to repeat until 33. But if let's say you have 4, you're going to repeat until 5. But if you compare to the multiplication, where's the flowchart? Fixed number. Okay, this one. Okay, for multiplication, if your bit is 32, then you repeat only 32. You can see here. Draw. Okay, for multiplication, if your bit is 32, you're going to repeat until 32. If your bit is 4, you're going to repeat until 4 times. If your bit is 8, you're going to repeat until 8 times. But for your multiplication, for your division, where is it? For your division, okay, this one. For your division, you need to add extra 1 more times. So if you have 32 bits, you're going to repeat until 33. If you have 4 bits, you're going to repeat until 5 repetition. If your bits is 8, you're going to repeat until 9 repetitions. Let's take a look into the example. Okay, this one, you have the equation of 7 as why it didn't show the what the division, why it didn't show the I forgot the name, the divider. You can see it's only show you on the divisions because the options in the flowcharts only looking into the divisions and quotient and divisor, quotient. So it's only referred to quotient and divisor, but for the multiplication it's slightly different, isn't it? You have like product which is quotient over here, so it's slightly different. I don't want to make you confused. Please make sure you remember that. Okay, now divisor. First divisor is slightly different, which is when you place your divisor. This is your divisor. Last time normally you're going to put like this: 0 0 0 0 0 0 1 0 s equal to 2, right? But for this multiplication, you're going to swap the place. You will put 0 0 1 0 in front and 0 0 0 0 beside here. And you're going to have the quotient first for 0 0 0 because you don't know basically the answer first, right? Initial value. So the remainder for your initial value, this one you're going to put 0 0 0 1 1 1 here. So the only difference is at the divisor, you're going to swap left and right. I think there is information over here. It didn't show you, or maybe it's mentioned somewhere here. I think I'm going to find the keywords, but it's okay as long as you understand. You can see there is a what I can say, not a reminder, information maybe for you to memorize that for divisor, start at the left half first of divisor register. So in terms of the value 0 0 0 0 0 0 1 0, you start on the left half, which is over here, right? You're going to start first, and then this one will start later. So that is the rules when you want to use the divisor method. And your quotient first will be 0 0 0, and this is the value. for your 7. Okay, now you can see, because this one is your initial, right? You can see you have quotient, which is you don't know. Basically at the initial value, your remainder will be 7 because you're not going to divide with anything. And first step, which is subtract divisor, which is this one, you're going to subtract from remainder. So this is your remainder. You're going to subtract and place the result in your remainder. Means that you're going to place inside your remainder equal to remainder, your current remainder, minus with your divisor. So you can like try directly minus and deduct it. You're going to get 11100111. This one is minus d. You can apply like plus minus d, which is this one is -2 value, right? Just now going to like for early stage, what you're going to do is you're going to put like this. So for first, you're going to do like this, which is you're going to subtract r minus with d. And after that, for second, you need to check whether your remainder is 0 or not. Of course, it is not 0. Where you going to go? Not 0, more than... no, this one is negative. Let me check. Okay, for this question, it asks you to convert it to... because as I mentioned over here just now, you have r minus d. Then you will get r plus minus d. This value, as mentioned, this is negative. We're going to do the second complement. How we're going to do the second complement? First, we're going to change it into first complement. 0 to be 1, 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 1 to be 0, 0 to be 1, 0 to be 1. After that, we're going to add with 1. This is our second complement answer. So after we have this, we're going to add. With this one. So when we add, we have 0, 0, 0, 0, 0, 1, 1, 1, add 1, 1, 1, 0, 0, 0, 0, 0. So we will get 1, 1, 1, 0, 0, 1, 1, 1. So let's check our answer. It's similar. So that's why we get this answer. Again, I repeat. First of all, when you have a question like this, what you need to do is you need to divide this into quotient, divisor, and remainder. And there is a rules for divisor. You need to pick like a vice versa, bit change. For left, you will put first, which is you have 0, 0, 0, 0, 0, 0, 1, 0 equal to 2. And this part, you're going to put letter. This, your left side, you're going to put first. And for the remainder, it's okay, it's similar. and the quotient first is 0. There is no value at the starting initial value. After that, for first step over here, it is equal to r minus d, equal to r plus minus d. What is your value for minus d? You're going to add second complement because it is negative number. First, you change it into first complement, and then you change to be first complement. There is a carry. So this value you add to your remainder here, 1110 0000. That's why your answer will be so. Let's take a look. Okay, now after you get the answer here, you need to check. You need to check whether your remainder is more than 0 or less than 0. So your remainder over here, what is the value? So you need to check the value. Normally, if like you see over here, we know that this is negative number, but you can like directly convert back to the value. You are using the first complement to second complement again. Then you will get the value. And then you convert it into second complement. Then you check what is the value, whether the value less than 0 or more than 0. But you can see also here, this is 7, this is 2, and you minus, you need to subtract, right? Remainder minus with d. So what the value will be like more than 0. So you're going to have, why it is minus 2. Test remainder less than 0 or remainder more than 0. It's supposed to be 2a. It's okay, let's take a look. In here it says that it is 2b. Why it is 2b, which is r less than 0? Then it's going to be r equal to d plus r again. You will get the value. Why is mentioned r equal to 0? Why? Is it the keyword here, which is negative number? So can you figure out why it mentions that remainder less than 0? You can see for 2a it is more or equal to 0. Please try to figure out why we need to have 2b there. And then you're going to see, you're going to continue like shift left and then shift right, which is similar things. You're going to repeat using this flowchart and similar to your multiplications. But you're going to repeat until 5 times because your bit is 4. You're going to repeat until 5 times. Try to complete the tables and the remainder, etc. So this is your answer. Later on we can also discuss it in our class. There is a several exercise. I believe you can see also in the notes. I think only that for this video. Later we're going to continue our floating point, floating arithmetic. This one is not too hard also, but it's much more complex rather than our integer value or integer number. If you compare to the floating point of fractional number, normally I call it as a fraction number. And lastly, we're going to finish, I guess by today we're going to finish also all our module 2. Then it's easy for us like to move to our lab 1. And yeah, your test is only cover, test 1 is going only cover lab 1, module 1 until module 2. So I guess we will meet in our class and we will discuss again, and especially we're going to finish our floating point in representation and also arithmetic. Thank you for your watching this video. Bye bye.